Okay, now we get to something called indexing. If you've used C or any number of other languages, you've probably done a lot of indexing. You've probably seen a lot of indexing. There are some tricky things to it. We'll see exactly how it works in code in a couple of screens. But the basic idea is you take a string, and then Python numbers the letters, does this internally, essentially numbers the letters from 0 to n minus 1, the individual characters, I should say. And this is where n is the number of characters. This is called zero-based indexing, incidentally, and some people find it counterintuitive at first, even though there's good lower reasons for it based on low-level operations. But you just have to remember the indexes run from 0 to n minus 1. So if we take a string, the Beatles, which has 10 characters, it doesn't go from 1 to 10, which you might expect. The numbers corresponding to the characters go from 0 to 9. Now, a special feature of Python that you will find in very few languages, and this is not something you ever have to use, but you might want to use it, and you want to be able to recognize it in other people's code, is that there is another method for indexing a string, and you can use either one and you can use them interchangeably. You can also use negative numbers to refer to characters in a string, and they run from -1, which gets you to the end of the string, all the way to -n, which gets you to the beginning, where once again n is the number of characters in the string. And so this is really cool because it just gives me another way of referring to the same characters but with different numbers. And sometimes it's more convenient to use positive numbers, sometimes it's more convenient to use negative numbers. So let's take a really simple example. So s equals hello. So how do I refer to the first character? How do I refer to the first character in the string? Now remember, it's not 1 to n, it's 0 to n minus 1. So the first character is 0. So how do I print the first character? I say s, and now I use the square brackets. It's always the square brackets with indexing. And I say s sub or bracket 0, close bracket, 0, remember, first character. So if I say s bracket 0 bracket, I'm going to get the first character, which is a capital H. And when I refer to the second character, I'll say s bracket 1 bracket, and that will give me the second character. That gives me a lowercase e, and so on. But once again now, we're going to run into the fact strings are immutable. Immutable means unchangeable. So therefore, if I use indexes to try to modify a string, what is Python going to do? So once again, I say s equals hello. This time it was lowercase h, and I want to substitute an uppercase h. That's a very common operation. So I go ahead and try it. I should be able to put the index on the left side to say change this one letter. And if I try that, Python will complain. It'll say, no, you can't do that. Strings are immutable. You cannot change string data. So what do? I'm stuck. What do? I say it's wrong, it's a typo. I need to put a capital H there. Well, what you do is you say s equals capital H, hello, and that works. Why in the world does that work? And the reason that works is because I'm assigning an entirely new value to the string. It's not changing string data. It says I'm going to set s equal to a different string. And that's fine. I can always assign values to a variable. I can reassign values to the variable. It's perfectly okay. So if I try the first approach to changing string data, it won't let me do it. But if I just assign a whole new string, it says fine. So now let's move to something that even if you've programmed in other languages may be a totally new subject to you, but it's really awesome. Just as I can use indexing, there's a variation on indexing called slicing, which is very, very impressive. And slicing looks like indexing. It uses the square brackets, but it uses two different fields at least. And if I say string bracket A colon B bracket, this actually gets me a substring. And how do I read this? You need to read this correctly. What this syntax says is it will start with position A, and that's an index, and it will give me the entire string up to but not including B. Now that's a little tricky because we're including A, but we're actually excluding position B, and I will show some specific examples. I can also do variations on that. If I have a first argument but not a second, it will start with position A and it will go to the end of the string. Conversely, if I have a second argument but not a first, it will just start with the beginning and it will go up to but not including B. And finally, I can omit both, in which case it will just copy the whole string. By the way, that is sometimes useful. That sounds like a pointless operation. It's not, because that's actually the only easy way, or one of the few ways, to get a completely new copy of the same string. But if I get a copy, I can do things with it and retain the original value. So sometimes that's useful. Now, okay, what I promised, examples of slicing, because I don't think you can really understand it until you see at least a couple examples. So I start with a string called Dragonfly, or at least it contains Dragonfly. It's called my star. All right, let's look at an example. If I say 0:6, what am I saying? I'm saying start with position 0, and I get all of the string up to but not including position 6. So remember, I'm going to include position 0. I'm not going to include position 6. I'm going to get everything up to that. So look at the display here. We see that 0 gives you a D. You then get all those letters, but you don't include position 6, which is F, so that gives us dragon. Now, what happens if I exclude the first argument? It's going to start from the beginning of the string. So it's almost as if I put a 0 there, get the same result. So :6, just give me the first 6 characters. Give me everything up to but not including position 6, which is actually the 7th character. So again, I get dragon. And then the last example uses negative indexing. So it will say start with position -3, which is the F, and then give it to me up till the end of the string. Just give me everything. And it gives me fly. So if you look at these examples, actually if you go and experiment, you go and do some experimenting on your own, this will make a lot of sense. The only tricky part is that second coordinate is up to but not including. So let's look at a demo. Okay, and I'm just going to repeat these examples that I went through. First of all, the string, before I can index a string, there has to be a value in it. And let's spell dragonfly. All right, and if I type the variable name in, it will show me what it is. It's dragonfly. Okay, great. I'm going to slice. I'm going to do some slicing. And so what if we say first argument is 0, second argument is 6. I said this will give you dragon. It does. So it outputs dragon because it started with the D, first character, everything up to but not including the F. Same thing if we go :6. I'm omitting the first argument, so it's just going to start from the beginning of the string. Do the same thing. And I can do -3, which is starting with the F. Colon means forward to the end of the string. Boom. So it does everything I said. But I could do stuff like this. So you can get into Python and you can play around with this. What if I said, let's do one more. We say 0. Well, actually, I'll do a variation. I'll say 1:4. What should that get us? Well, it should start with the R now, because 1 refers to the second position. It should start with the R. It should give me everything up to, but not including the O, which is position 4. And let's see what it gives me. Yes, it gives me rag. So if you've been following what these things mean, it's working perfectly. Now, there's also a possible third argument to doing slicing, which is completely optional, but does some interesting things. If I include a third argument, so it's something colon, and then the third argument, we'll call it C, it tells how quickly to go through that string. So if I put a 2 in there, it will pick up every other character. If I put a 3 in that argument space, it will pick up every third character. So I can not only get substrings, I can get all kinds of interesting variations. But here's where it really gets fun. If C, that is the third argument, is negative, it actually changes directions, which means it goes backward through the string. So what if I leave the first 2 arguments blank, which means it's just going to go as far as it can, do as much as it can. But I put in that -1. What do you think it will do? What will it do if I leave everything blank, but I put in that -1 as the third argument? What in the world would that do? Well, if you think about it, it goes backward through the string. It will give me the reverse of the string. So Python gives you an easy way using slicing, just get the reverse of the string very easily. And what can we do with the reverse of a string? Well, there's something called a palindrome, which is fun. And to do the complete palindrome program involves a lot, but I can do a simple palindrome test just by comparing a string to its own reverse. And we can do that, say, with the word race car. Is it equal to its own reverse? And we'll go ahead and do that quick test in a demo. I'm going to say a stir, again, I can give it any name I want, but I'm going to call it that. And I'm going to give it the name race car. And I want to see if this string is equal to its own reverse. Now, what do? I use a test for equality. But rather than testing the string against itself, I'm going to test it against its own reverse. If a string is equal to its own reverse, then it's a palindrome. Oh, true. Okay, great. And yeah, you can see that this is right, because if you just print out the reverse of the string, you get the same word. But that doesn't work with other words. Is the word dog equal to its own reverse? Well, let's try it. A stir equals dog, okay? And if we test whether dog is the reverse of itself by using the -1 to reverse direction, no, it did an assignment. Okay, let's try that again. We don't want to do it. I just showed an example of why you do not want to confuse double and single equal signs. This is an assignment. Now we want to do a test for equality. We want to say, is a stir equal or not equal to its own reverse? False. So it's not equal to its own reverse. And we know that because if you reverse dog, you don't get dog, you get God. So it's not a palindrome. Now let's look at some other really common operations of strings. As I said, strings are wonderful in Python, as all data types are wonderful in Python, because they come with all these built-in methods. And I call a method just like a function, but I use the dot notation. So if I use the upper method on a word with mixed lowercase and uppercase, it will give me the all uppercase version of that word. So s.upper in this case would give me race car, all capitals, and lower would give me all lowercase. Another method used a lot with strings is called the strip method. And if I want to strip a string, what it will do, by default, it will remove all leading spaces that can be very useful when I'm communicating with the user or want to format text, and it will remove all trailing spaces. Strip also takes optional argument that can be any character I want, but by default it's spaces, so it's going to strip leading and trailing spaces. It, however, does not strip internal spaces, as you can see. So let's summarize indexing and slicing strings. It's actually a lot to digest if it's all new to you. Indexing a string returns a single element. And by the way, when you index a string, you cannot use an out-of-range index. You will get an error. So indexes, that's when you use just one number to get a single character. It must be in range. You can use non-negative indexes. This is what most people do. It's zero-based. That means it goes from 0 to n-1, where n is the length of the string. You can use negative indexes, which run from -n to -1 in reverse direction. Or you can use slicing. Now, slicing is a little different from indexing because if your indexes are out of range, it simply gets as big a substring as it can. So you will not get an error. You will not get an out-of-range error when you do slicing. But in any case, you will get a substring. You might get an empty substring, but you will get a substring. And the basic idea here, the basic syntax is we have two arguments usually. The first tells you where the substring starts that you're going to produce. And then with the second, you will get all the characters up to but not including the second position.